Saxon Algebra 1/2 lesson 68. Percent word problems. Are you ready? They're going to be really, really fun, I promise. But the first one is the most annoying one, if you want my opinion. And I would do this one differently than a lot of the other problems. So we're going to start by breaking the rule, okay? Or at least the pattern. Sales tax is 5% in Maryland. I bet that's not true anymore. Joey bought a pair of basketball shoes advertised for $62. How much sales tax did he pay? Okay. And you probably know that the way that we find sales tax is we take 5% and we multiply it by the basic amount. That's equal to 5%. Let's just leave it like that. Do you remember the problems that we did where we figured them out by saying, okay, what's 1% of 62? And we could write this as of or as multiplication. 1% of 62 equals point, right? We move it the decimal place twice, right? 1, 2. So it's 0.62. And so 5% of 62 equals 0.62 times 5. And we'll do that right over here. Right? We'll do our multiplication over here, neat and tidy. Wait, I mixed that up. Oh no, I didn't. 1, 2. 1, 2. Right? 2 places go behind the decimal. So, the amount of sales tax that our boy had to pay was $310. $3.10 is the tax. A word problem deserves a word answer. All right? We could have used the freaking formula, but it's way more complicated. This approach of saying, okay, if 1% is this, then 5%, we just multiply that, whatever it is, by 5, right? Or the 1%. This is the easiest way to do this one. And I don't like to see this problem as a freaking formula style problem because it adds all kinds of complication to it. So sometimes if you see an easy way to do the problem, do it the easy way, right? The big baby weighed 15 pounds. Mama weighed him a week later and he weighed 18 pounds. Mama could not believe it. A 3-pound increase. Mama wondered, what percent increase is this? Okay, so let's draw a picture. We've started doing this, and in fact, in just a second, we're going to start doing that more. We always start with a before, and then we draw the after, okay? Sometimes I put an arrow to remind us of what that means. Sometimes I just write before and after, right? Now, in this case, our baby is not the same. He got bigger. So I change my diagram to show the first amount is increasing. Now, this might not be proportionate. This looks like the baby doubled in size and then some. Not our baby. So this baby started out weighing 15 pounds and then he weighed 18 pounds. We know that in the beginning it was 100% because that's how these problems always work. And we want to know what percent increase that was. Okay? So what we know, oh, you know what? I'm doing this the hard way too. No, it's fine. This is a good way. So we know the percent over 100 times of equals is. I think we've done this before, haven't we? Have we used the P over 100? I think so. So that's what we want to find. P over 100 times 15 equals 18. Does that make sense? Our baby got bigger, so that's the after. And we want to find out what percent that was. So there's our P. we have to multiply by the reciprocal to make that all cancel out. I'll do it on both sides. I'll put this over a 1 so that it looks normal. The 100 cancels there and the 15 cancels there. You can put the 15 over a 1 if you like that, so it doesn't look like it's just floating. Okay, so this p's by itself, and now all we have to do is clean this up. 15 and 18 are both divisible by 3. 3 goes into 18 6 times. 3 goes into 15 5 times. Ooh, 5 also goes into 100, right? 20 times. So this becomes 1, this becomes 20. Now, these are both even numbers, but they're in the top, so we can't cancel them. Once we see the bottom turn into 1s, we know that we've done all the work we can. What we find is that this ending percentage is 120%. That means the baby's new weight is 120% of his old weight. That means when it was before 100 and after 120, that means the increase in the baby's weight was 20%. Does that make sense? He was 100%. He's now 120% of his old weight. So that means the increase is the difference, 20%. All right. Just so you know, John approached this tax problem by turning it into a freaking formula problem. No bueno. I didn't like that at all. This is so much easier. This is a better way to do it. When you're doing a sales tax problem, just find the 1% and then multiply it up to get the whatever percent you're looking for. Okay, that's enough of that. Let's move on to some more freaking formula problems. I'm excited. Ready? Oh, okay. Complete the following percent diagram by finding A and B. Okay, now John is drawing these as squares. Let me just show you. He's drawing these problems as squares. Soon enough, he's going to change to circles. I like circles better. So if you want to draw squares like John, that's fine. But I'm going to go into circle mode. And you'll notice that what John does is he writes before and after. That's cool. That helps us see how things are changing. The beginning one is always 100%. And in this case, he's got a number in there. He wrote 600. Okay, now we also know that this is always the of number in our frickin' formula, right? Let's see. I'm assuming we're going to keep using the percent version, right? So the of number is always in the first circle. Now, what's happened is John has divided the second one, and he's got 180 here, and he wrote A, and then he wrote B, and then he wrote 70%. Okay, so what we can see is that 600 has been split into 2 groups, and we're supposed to find the number in each group, and we're supposed to find the percent in each group. Now, we can use this formula, that's for sure, but John has made this one so easy that we don't even need it. The first thing he wants us to find out is what is the percent of this top group. Let's say that these are some clowns, and these are the clowns that were evil in their hearts, and these are the clowns that were not evil in their hearts. If 70% of the clowns were not evil in their hearts, then we know automatically this had to be 30%, right? Because it has to add up to 100. Okay, that's really easy, isn't it? Okay, and then I'm just checking the answer. That's correct. Now we're supposed to find out how many actual clowns were not evil in their hearts. We know we have 60. This many is 180, which we can easily see. Oh, if you multiplied 0.3 times 600, you would get 180, right? 3 times 6 is 18. The decimals fix out otherwise. So we can really easily figure out, oh, 7 times 600 70 times 600, right? That has got to be 420. So I did that in my head. I really fast went 70 over 100 times 600 equals B. And I did this in my head super fast. There it is. There's the 420, right? The other way we could figure it out, though, is to say, okay, total clowns 600. The ones who have, I don't know, what did I even say, evil in their heart? Subtract those, right? We can just do it as a straight subtraction problem. So in this problem, John gave us enough information that we didn't even have to use the freaking formula, which is fine because he was just trying to get us used to this whole diagram business. Let's try another one. This one has a story, and I think the stories make them more fun, even if they are about clowns with evil in their heart. Ewan was a smart shopper. He got a great kilt for $433.65. It was 30% off the original price. What was the original price? Okay, this is a real life situation, right? Where we're trying to figure out sales percentages. All of my daughters at one time or another have worked in retail stores. Abercrombie, Hollister, The Gap, Eddie Bauer have all been in the employ of one of my daughters or another at one time or another. And they all tell stories about how people come in and there'll be a sale. You know, they want to buy something that's $49.95 and it's 30% off, and they don't know how to figure that. This problem teaches you how once and for all. It teaches you a very complete way. Okay, so here's the original price. That's like the before, right? And then here is the after. This is on sale. We're not going to pay all of it, right? We're going to pay, this is the sale price. And this is the amount. If it's 30% off, that means we're going to pay, say, 70%. And we don't have to pay the 30% that it's quote unquote off, right? So we call that the discount. That's what we don't have to pay. All right. We know that the original is always 100%. And then we're going to have separate percents, right? We write those to the side. All right. He got a great kilt for $433.65. That's what he paid. You're writing all this down, right? I hope so. I wish I could look through the camera and see. It was 30% off the original price. Okay, now we know that the 30% off you don't pay the 30%. The 30% is what you don't have to pay. So that means the 30% goes down here, right? We don't know the original price. We don't know what the discount was, but we can figure out the percent. John tells us we didn't figure it out. That means that our friend Ewan McGregor, I'm assuming, he would be buying a kilt, would he not? And P.S. I have a neighbor that was one of those guys. I haven't seen him in it lately, but he does wear a man kilt fairly often when he rides his Harley. So just put that in your mind. Okay, so if the discount was 30%, that means he paid 70%, right? That has to add up to 100. Now we have enough to make a frickin' formula because here is the of will be our mystery. This is our special group, the amount he had to pay, and this is our percent. Okay, so those are the three, or the is. And there's our of. All right, that's always going to work in these problems. That's how we can find the numbers we need for the formula. The percent is over here, depending on which group we're interested in. The is group goes into one of these blanks, and the of group is what we start with, always. All right, so let's work this out now. We know that our percent is 70 over 100 times this. I'm going to call it X. John often calls it WN, standing for what number. That's fine. Whatever you want to do. Make it your initial if you like. But this times X equals 433.65. Oh boy, that looks like it's going to have some rough numbers, doesn't it? Guess what? It's going to come out. It's going to be a little iffy when it comes out. All right, so what do we have to do? We have to multiply this by 100 over 70 to use the reciprocal and get rid of that coefficient. We have to do the same thing over here. 100 over 70. This all cancels. Now we have to sort this out with a minimum of fuss. Okay, here's what I'm going to do. 433.65 times 100. I'm just going to move the decimal place twice, right? That works for multiplying by 100. Then I'm going to divide by 70. So let's do that. I have 433.65, right? And we're going to divide it by 70. All right, 70 does not go into 4. 70 does not go into 43. But if I do 433, then I can think of it as 7 into 42. That's 6 times. But I want it to line up here because it's got that 0 in it. So this is going to become and I can bring down a 6. My problem's going to have to go kind of sideways. I hope that will make sense to you. Here, you know what I'll do? Wait. Let me use my special auxiliary book. Okay. 70 into 136. That only goes once, right? Because 2 would be 140. So that just goes once. So then I have 136 minus 70. That gives me 66, right? And then I bring down the 5. How many times does 70 go into that? Well, 7 times 9 is 63. So I think it can go in 9 times. 9 times 70 is 630. I subtract and I get 3, 5, and I can still... Oh, I've run out of things to bring down, but let's put in a decimal and bring down one more 0. Oh, but look, 70 into 350. It goes exactly 5 times. So that is my number for my answer. And that tells me what the original price was of this kilt. That was a pricey little quilt, wasn't it? Kilt, not a quilt, a kilt. So I fill in the rest of my formula. And now I can also figure the discount. I can take my original price and I can subtract the amount that I did pay, and I'll get my discount of $185.85. That is our goal. When we draw these diagrams, we want to fill in the original amount, the 2 special groups, if you will, and each of their percentages. All the pieces of information get filled in before we are officially done, even though this is our actual answer. Okay, in your homework, you have one just like what we just did. There's no story. You get to make up your own story about some group of something that was being split, right? These are all the kids who came to your house today. These are the ones that stole your M&Ms, and these are the ones that didn't. I don't know. Make it up however you want. These are similar kinds of problems. John just did not start it off for you. You have to draw your own pictures in those. Okay? We're going to be doing these for a long, long time, you guys. We'll have lots of chance to practice, and I will ask you in the video chat this week how they're going for you. Okay. Good job. Bye.